First and foremost, welcome everybody. Thank you for your time. Time is a precious commodity, and we're excited to share some of the content and some of the lessons learned that we're about to share with you. So first, I want to introduce myself. My name is Richard Moulton. I lead our partner sales organization within our AWS for games vertical. We focus on providing game solutions, cloud-based services that help them build, run, grow their games more effectively. I also want to introduce Joseph Morais, who is Principal Partner Solutions Engineer at Confluent, and Tim Vale, who is VP of Solution Engineering at StarTree. StarTree and Confluent are our two, I would say, superstar guests. They are going to be walking you through the value of their solution integrated into some specific use cases. Those use cases are player experience and engagement, anti-cheat and toxicity, game monetization, and also helping drive and enhance the game development process. Doing that all through real-time analytics and leveraging the value of their complementary platforms. So we are not only going to be talking about how we solve problems in each one of these use cases, but the outcomes that we deliver associated to those use cases, all very specific to gaming and all very specific to the gaming development, operation, and monetization aspects. I want to give you some kind of engagement, best policies or rules. First and foremost, we love interaction. Please use the Q&A panel to post questions, ask insights on some of the points that we're making. We will absolutely interrupt the content flow, answer your question, and make certain that we use that as an engagement and interaction process. The more questions we get, ladies and gentlemen, the better off we typically find these engagements. And last but not least, towards the end, or at the end, so stay, if you will, because there's a prize. We are raffling a Steam Deck at the end of the event. We're excited to give that away. That was through the graces of both Confluent and StarTree. And we want to make certain that, we're excited about giving away. So please stay to the end if you could. We'll do the raffle at the end. And with that, I just want to say thank you again and make certain that we value this time together. So with that stated, Joseph, Tim, floor is yours.
All right. So this is a subject that's very near and dear to my heart. So almost 40 years ago, my mom put an NES controller in my hand, a little rectangular controller in my little hand. Probably won't even fit in these big mitts anymore. But I've been gaming for a long time, right? And when I was going through this deck and we were preparing for today's presentation, I really thought about one of my favorite games of all time, Battlefield Bad Company 2. Right? And I remember PS3 era, first downloading the demo, playing through Port Valdez, and how incredible it was when I first shot a grenade launcher and it broke a wall and I was able to walk through that wall. And I started to think about, what would the analytics and the real-time data be for when DICE built Battlefield Bad Company 2 back in, I think it was 2008 at this point. I'm sure our analytics have grown, have been enhanced since then. But again, as Richard said, please do not hesitate to throw any questions in the Q&A. I think of them as real-time, quick-time events, so it'll keep me on my toes. So to kick us off, let's talk about enhanced gamer experiences with Confluent, StarTree, and AWS. So first, let's talk about data in gaming. So there's all types of data you can choose to collect when you're talking about gaming, right? You have player movement, chat, clickstream. You also have to think about things like latency and throughput. And that allows you to engage with your gamers, monetize their player behaviors, and enhance the game development cycle. The key, though, is you want to be as real-time as possible, and you need to be highly available, and you need to be able to handle massive throughput. So whether you are one of the biggest game providers in the world, like an Epic Games, or you're just starting out, you want to make sure you have a platform that can scale because we want you to be successful. So whomever you're looking to partner with when you're building the next great game, have these things in mind. So how does that relate to data streaming, right? Data streaming allows us to set our data in motion, right? So if you think about all that clickstream data, all that telemetry, works very similar to other verticals out there in the world, whether it's an in-game purchase or a ship feature or swapping items. All of these things are simply events, right? So what is an event? Event is something that happened, right? And that is the reason that Kafka and Confluent were built in the first place, right? The idea that We need something that can transact events at massive scale with low latency, but also had some persistence layer. And why do you have that persistence layer? For, well, many reasons, right? You have things that are going to react in real time, but you may have microservices that do things in micro batches. So that persistence layer is key. And of course, scalability and high availability. Those are always going to be important. So all of those events which you see on the left side, lead to outcomes, which when we're talking about Confluent AWS is a very important theme. Things like rich front-end customer experiences and real-time back-end operations, both which would be crucial to having any type of successful gaming platform. So let's talk about not real-time versus Confluent, right? If you think about matchmaking, when you're doing real-time, that's competitive, right? Our most hardcore gamers, they want to be able to matchmake, and they don't want to wait minutes to get into a match. They want to wait seconds. And if you can give it to them in less than seconds, that's even better. When you think about toxic player detection, if you're doing this with batching, you're probably going to have a large list of toxic players. You're going to scare away all of your good players that you want to really be part of your community. And without kind of reading through each of these, you can kind of see with real time, you're getting the best inside of that particular rubric. If you're dealing with not real time, again, it's all best effort, sometimes not even available, things like launch day adjustments. And then, of course, advertising, right? Targeted advertising. It's like gaming. I don't think any of us love to see advertisements and things, but I do, at least me personally, would rather, if I'm going to see an advertisement, see something that's relevant to me. And real-time data allows you to unlock all of that. So let's talk about some gaming industry challenges, and we'll talk about how Confluent can help address those, and StarTree as well. I don't want to exclude our friends over there. So unpredictable demand and life cycles, right? Who knows which of your games are going to have some streamer live stream it and go absolutely viral, right? When I think of it's going to bother me, the name of that game where you're out in space and everyone has the different color uniforms and somebody's the bad guy and you have to figure out who like the alien is.
Among Us?
Among Us. Thank you. Tim saved me. That game was out for 2 years before it went viral, right? And then suddenly they had to scale up very quickly to meet unprecedented demand. Large daily and seasonal demand swings, right? Of course, if we're talking about online gaming, Christmas morning, probably going to have a spike in gaming, just kind of the way it is. You want to be prepared for that. And you also want to be able to cost optimize for when you're going through low periods. So you need something that's elastic. Small teams, tight budget, specialized skills. That's how most of us kick off really great games. And when we start, we don't all work for gigantic gaming houses that are going to have everything. Sometimes they're just small, and you really want to have a trusted partner to run things that you don't necessarily need to run yourself. Fickle and connected customer base. This is an important one, right? I think there are, when I think of strong fans, I think of sport teams as probably the first thing that comes to mind, but gamers are right behind there, right? Like absolutely die hard for their brand, die hard for the particular series that they love. And of course, if their game's not working, they're going to be very vocal about it. Global product reach, diverse customer base, of course, so our games are usually played globally and we have to deal with localization and things like that. And then third-party integrations are the norm. I've been on some kickoff calls for some massively launched games, and I can't tell you the number of third parties that were on those calls to make sure that everything worked. I mean, literally dozens. And how do you interconnect all of these in I'm going to say it a lot, in a highly scalable, highly available, low code way. And we're going to talk about all of that. So again, to how Confluent addresses these, we can help with agile deployment and pay per use. So we have instantly provisionable clusters. So if you have a CI/CD platform, you want to spin up a cluster, throw some data at it, run an integration test and spin it down, you could do that, and you're only going to pay for what you're using. With those demand swings, scalability, pay per use, once again, is going to help you. Maybe you don't know what size you're going to get. So instead of building some massive cluster that is sized to your peak, you can start with a modest size cluster that can auto scale. Again, those small teams, fantastic TCO. We're going to talk about connectors. We're going to talk about stream processing. We're going to talk about the fact that this is fully managed data streaming. There are plenty of people out there that will say they can fully manage your data streams. But when you look under the covers and you look at some of the work you have to do to run over time, to scale up, to scale down, to ensure your latency is low, it's a lot of manual work. And if it's a lot of manual work, it's not fully managed. So that fickle connected customer base, 4 nines SLA for Confluent services, that global product reach, we can mesh clusters across geographies, across AWS regions. We have best in business or best in breed security and data governance. And then again, those third-party integrations. We have features such as stream sharing, stream lineage, security, and connectors that are going to make those integrations as easy as possible. So let's talk about let's talk about player telemetry and how much there really is, right? When you really think about a single player playing a game, and let's say an online game, right? Some third person or first person shooter that's pretty massive. You have their actions, their locations. They have a chat box. They have an inventory. They have interactions. And because this is an online game or like an MMO, all of that is really kind of written to the back end. The client is just there to kind of produce some of the graphics. We're storing very little of that in the client locally. On top of that, we have the platform. We have our servers, we have our latency, all which need to be able to work at our requirements with that massive deluge of data. And then there's the other side of the data, right? We have the demographic data, the games played, their purchase history, the player as it pertains to all of our player bases. When I think of Ubisoft does this. Across their games, you have an Ubisoft login, and some of the things and rewards that you get from Ubisoft directly are available inside of this little window inside of pretty much any Ubisoft game, right? So they're looking at the player holistically across their game suite, and what can you achieve being able to handle all of that data. So this is a bit of an eye chart, this one, so I'm not going to read out the whole thing. I won't do that to any of you. I know my eyes have degraded with years of gaming. But when you look at some of the big infrastructure use cases, log aggregation, event-driven microservices, and of course, real-time AI ML, a data streaming platform can help you with all of these, right? Because log aggregation means logs are very noisy, which means you need to be able to ingest them and process them into something that is useful, or perhaps sweep through them and look for errors or violations. And you want to be able to react to that in real time. Again, I'm going to say real time a lot. It's just kind of the nature of the basis. Event-driven microservices, right? I'm a former AWS solutions architect. And one of the things that we preach is the well-architected framework. And one of the big paradigms of the well-architected framework is loosely coupled applications. Having a microservice talk to another microservice can be brittle. Instead, having something in the middle, like Confluent, that can take your producers and your microservices, and data can produce, and the consumers in the background are ignorant to each other. So when you have to do rolling upgrades, or you have to fix something, and your events are no longer being consumed, your producers have no idea, and that's exactly the way you want it. And conversely, if your consumers are running, but your producers aren't, your consumers are just going to wait for the next event to come in. They're not going to tap someone on the shoulder and say, hey, where's my event? Of course, you should have a learning to know that your producers aren't producing, but again, this isn't a controlled scenario. So data streaming helps all of that. So let's talk about more explicitly. I've said Confluent a lot. And before I start this next section, just to give everyone a little bit of history, Confluent, our founders were the original committers of Apache Kafka back all the way years ago. I guess we're 12 years now on LinkedIn. StarTree is actually an artifact of LinkedIn as well, but I'll let Tim talk about that. I'm not going to steal his thunder. I've already wore the really loud shirt today, so I don't want to do any more of that to him today. So, we have been helping companies run data streaming platforms for a decade and a half, right? And it really just started with open source, but eventually we started to build out our own products for various reasons. Not everyone wants to run a self-managed massive open source Kafka cluster. It's a pain in the butt as someone who's done it myself. So let's talk about some of the features that are going to make that easier for you. So on the left-hand side, you have open source. right? Which I'm a massive fan of open source, but open source has its challenges, right? You don't necessarily have support. You're not going to get all the nice fancy bells and whistles that we have, and these are some really nice bells and whistles. So looking at how Confluent differentiates real-time data ingestion, real-time data integration, excuse me, stream processing, enterprise security, and governance. And in this case, what does governance mean? Governance means we can control the data that ingresses to our system. Not only can we make sure that it has the right schema, has the right fields, has the right field types, we can also enforce validation rules that says, hey, this value for this particular field, social security number, is not 9 digits. It has a letter in it. We're going to reject that. It's 4 digits. We're going to reject that. It's 12 digits. We're going to reject that. Ensuring data quality as it ingresses your system, really powerful, for almost any use case, frankly. So we also have, both a directly deployable solution in what we call Confluent Platform, and we have our fully hosted Confluent Cloud on AWS. So again, having that mix of being able to deploy things to say the edge, if you have an edge type of scenario, or let's say you still have your own data centers and you have data there and you want to be able to easily connect all of those data sources to the cloud, Confluent can be your best friend. So cloud native, right? So again, we built a cloud native offering of Kafka, our data streaming platform. To that end, if you're curious about what that really means, it's not just marketing fluff. We actually built something that I'm very proud of. You can look up Kora, Kora. We had a award-winning paper, basically the system that we built to run cloud native data streaming. And again, these numbers are from years of case studies, right? What it takes traditionally to build massive Kafka, the time to ramp, the time to get to market. Unless you have engineers that know Kafka really well, it's going to take you 2 years, from soup to nuts to really get something launched. But if you take that same amount of undifferentiated heavy lifting, partner with us and use Confluent Cloud, we've seen these 2-year cycles shrink down to 6 months, right? Because what you want your engineers focusing on is building the logic for your game, not running databases, not running instances, not running Kafka, and not running Pinot later in the section. All of that, right? If someone said this to me, and it didn't really hit me until a couple of years ago, but they said the only thing worse than writing software you can buy is running a system that someone else will run for you. And as somebody who's been woken up, I have an ops background and had a pager before PagerDuty existed. That resonates with me greatly. And again, with all of you representing the type of systems in the world that can literally go viral, that is one of the best things that someone can do for you, is running at massive scale. And Confluent Cloud runs at massive scale, all the way up to 10 gigabits per second of throughput. And when you think about that, not just a network layer, actual events in and out, it's pretty massive. And again, for all of you that may already have excuse me,
Joseph, Joseph, let me interrupt you because we got a couple questions, and I think they're applicable to your.
Sorry about that. Yes.
No, it's all good. So one of the questions is if one of our customers is already leveraging Apache Pinot and Apache Kafka, what are the benefits of working with StarTree and Confluent? And you just kind of hit on those two tech stacks, so that might be a good point to just do a quick leverage of what you've taken those two open source constructs to.
Yeah, that's a fantastic question. So if you're already familiar with Kafka and Pinot, the pain that it is to run them at scale, right? And partnering with us basically means you don't have to worry about that anymore. You're now redirecting your engineering resources that are very precious, right? It's very hard to get good engineers. And you're now able to refocus their time towards the differentiated services that you're building that's unique to you, right? Running Kafka, running Pinot, that is not differentiated, right? It's part of our infrastructure. It's an important part of our infrastructure, but if you can hand it off to the world's experts on these particular technologies, you're just going to end up getting a better experience. Now you may say, well, Joseph, that might be expensive. And the truth of the matter is, on paper, it can be, but we go through extensive TCO modeling, total cost of ownership, where we think about what is the cost of downtime, right? What is your cost if your system's down for an hour? Worse, a day, right? Or what is the cost of those hours that your engineers are, updating and patching, or, adding new brokers because you need to scale up, and all the tools that you have to run to repartition and move the data around. I mean, when you think about that, especially at scale, right? If we're talking about little tiny proof of concepts, you should spin something up yourself to prove that your stack's going to work. But when you're going to production, to have these trusted experts there to not only help you with the running of the system, but the development of it as well, right? Because it's one thing to say I have this thing up and running, but how do I integrate it with my apps? How do I build my first data streaming application? Having all of that support from literally the world's the best experts at these particular technologies, I just think is fantastic. Tim, do you have anything to add?
Oh, I think you nailed it. It's StarTree. We, as you'll come to learn, kind of the founders of Apache Pinot, and we employ the folks who not only built it originally, but have run and operated it at some of the world's largest companies. And having those folks at your disposal to help, bounce ideas, questions off of, and ultimately support, your development and your rollout to production, it's just an incredibly valuable thing to have. So we're really proud of the engineering and product teams that we have that help, our customers, get to where they want to be and really share that experience that they've built up over many years running, as you correctly pointed out, pretty complex stuff. So you kind of want somebody in your corner with you when you're doing this stuff.
Absolutely. Richard, were there any other questions?
There was. Thank you, and gentlemen, good address of the questions. And maybe this is somebody who's got some expertise in both your technology platforms, or specifically with Pinot and Kafka. So the question is, there's some overlap between Confluent stream processing and StarTree Cloud. Do you see them as complementary or competitive in terms of those particular functionalities?
That's a great question. I'll start, but I'd really like Tim to add in on this as well.
Yeah.
So, yes, you can do queries from KSQLDB or Flink SQL. They're very powerful. But there are StarTree can not only query Confluent, it can query other things, right? So if you have multiple data sources, it's a no-brainer to use StarTree because you're only going to get that one subset. But I do think of them as complementary, right? I think stream processing, we have this whole concept of shifting left. The idea is that you want to do your processing as close to the source as you can. And I think there's a world for that, right? If you have, let's say, multiple data inputs and you want to combine them into a single event, I think Flink or Kafka Streams would be a great place to do that, right? Do your merging, your filtering, like get all the bad data out as soon as you can. And then you're left with what we call a data product, right? This is something that is meaningful, usually comes from multiple data sources. Then you can expose the data products to StarTree and allow them to do the really deep analytics, visualizations, et cetera, et cetera. What's your opinions on that, Tim?
No, it's a great question, and I'm glad actually it was asked because this was something I definitely wanted to cover. Because I think you're right. Kind of superficially, you can look at the technologies and, well, geez, aren't these the same, or couldn't they be the same? And I think the answer is, exactly like Joseph said, and I'll take it a step further and say that, in fact, not only are they complementary? Oftentimes they can be used together for reasons which I'll explain a little bit as we get into some of the kind of the architecture of almost like a before and after. But we work, as I'll talk a little bit about just kind of the founding story, work incredibly well, with the folks at Confluent, Apache, Kafka, certainly, and there is plenty of room in a really well-developed, well-thought-out architecture for both of these technologies for reasons hopefully that will make sense toward the end of presentation. So not I don't think a hair of competitiveness, even though maybe superficially it kind of looks like there are, they actually work really, really well together. And so hopefully that'll make sense in the end. And of course, if it doesn't, you can always reach out to us and ask us for more detailed responses. But I think it's a great combination of technologies.
Fantastic. Are we good, Richard, or do we have anything left?
That's good. Nice job, gentlemen. Thank you for those responses.
Thank you. I appreciate it. These QuickTime events, they keep me on my toes. All right. So again, when you think about, so we have multiple attendees. We're really happy for all of you that are in attendance, right? Whether you're a developer, operator, architect, or executive, there is meaningful features to what we've built over Apache Kafka. So Kafka, you can see that bar right there, kind of not quite in the middle. It's about 2/3 of the way down. That's kind of what you get. All these other features that you see below it or above it are what Confluent brings to the table. So whether you need multi-language to support, you need a rich pre-built ecosystem, we're going to talk about that in a bit, whether you need event streaming or an event streaming database, excuse me, or you need data compatibility, or you need a TCO analysis, or you need support, training, professional services. Confluent brings all of this to the table, right? And trying to do this on your own, probably impossible to make up all the hours and experience that we built. It's just, this is what we do. Let us help you do it the best. So we're going to talk about our connector API. So in addition to the consumer and producer API, right, the API that allows you to produce events to Confluent or to consume events from Confluent, there's another really exciting API called the Connect API. Now, the Connect API allows us to connect things, right? Pretty apt name. It allows us to take things that are data sources, like a relational database or an object store, and take those objects or those records and capture them as events and emanate them into Confluent. So let's say you have some legacy relational database and you still have one of your games writing to that, but you want to incorporate that data into your central nervous system, is what we like to call it. You can use a source connector to do that. So we have every flavor of relational databases out there. And then we have the opposite. We have syncs. So let's say you built this great data product. You do some stream processing. You're very proud of your event and you want to go stick it in some downstream service. Maybe it's MongoDB Atlas. Maybe it's DocumentDB. Who knows? Whatever your flavor, whatever you like, we have connectors that will allow you to then sync those events in there. So now this Connect framework builds this connective tissue of I have all these disparate data systems all over the place. Well, we have connectors for all. And I just wanted to highlight a few specifically on AWS that we're extra proud of, whether it's SQS, S3, Kinesis, DynamoDB, etc. And then, of course, every flavor of RDS, right? We have others there, but I really wanted to highlight some of my favorite connectors here on AWS. So if you're curious about the connectors, you can check out hub.confluent.io. You can see the whole list of them. And many of these we offer in fully managed, which means inside of Confluent Cloud, you don't have to run your own connectors. You basically say, I want this connector, give it a host name, give it your authentication, and it starts pulling or sending data for you. Really powerful piece of technology and something you don't get with open source. With open source, there are connectors out there, right? Absolutely, some popular connectors, but they don't come with SLAs and they don't come with support. And many of these connectors are not open source. They are commercially licensed and only available from Confluent. So I highly recommend you check out Hub, especially if you're trying to do any data integration. One of the other things that we can do is we can be everywhere. I alluded to it earlier, but we have Confluent Cloud, right, which is fully managed on AWS in almost every single region. And if it's not in a region, other than like US West 1, but ignore US West 1, that's, you can't kind of grow there. But, any other region that is especially new, if it's not there, we can turn it up very quickly at customer demand. And then we have Confluent Platform. This is our enterprise distribution of Kafka. This allows you to run it on-prem in one of AWS's edge services like Outpost, Wavelength, or Local Zones, in your colo, or kind of anything in between. And so with connectors, we allow you to get your data into these Confluent clusters. But what about data between Confluent clusters? Great question. So another technology we have is cluster linking. So this is best in breed replication technology for Kafka. So you may say, hey, Joseph, I've heard of MirrorMaker 2. I've heard of your own Confluent replicator. Those are great. They sit on top of the Connect API. So they need an additional layer. Cluster linking doesn't do that. Cluster linking uses the internal replication mechanisms of Kafka, the way that Kafka can ensure scalability and high availability, and links it across clusters. right? So whether you have, a Confluent platform running in your data center and Confluent Cloud and running in AWS, you have a beautiful direct connect pipe between the two. You can set up cluster linking, and suddenly you now have your path to bridge your data from on-prem with all those connectors into the cloud to do something amazing downstream with it. Maybe you want to work with StarTree Cloud or a bunch of other services, and you have that freedom. So cluster linking, so a combination of connectors and cluster linking allow you to connect all that data regardless of where it is. And then the last piece of this is the stream processing, right? That whole shift left, the question that was asked, the very good question that was asked earlier. And we have quite a few of options for that on the Confluent side. So the last API, which I didn't talk about, is the Streams API. So the Stream API allows us to build basically microservices in either Java or Scala. I always say Scala, it's Scala, like ska music that was really popular in the 90s. That's how I remember it. To basically, lower the footprint in terms of coding, right? You basically import this library. You can start interacting with these events in real time, do transformations, filtering, merging, all the logic that you want to apply against your data streaming platform. And then we have a visualization or an abstraction of Kafka streams called ksqlDB, which was built for people like me who are not Java coders, but I'm kind of dangerous with SQL. So that's what ksqlDB was there for, to give you that abstraction layer to do very similar things that you could do with Kafka streams, but with that SQL-like interface. The future, however, is Flink, right? So Apache Flink is another Apache stuff. So we got Pinot, we got Flink, and we got Kafka all in one session. We're getting kind of loaded here, right? But Confluent made a acquisition a couple of years ago of a company called Immerok, which had quite a few, half of the committers of Apache Flink. And now we've built Flink fully managed on Confluent Cloud on AWS. And we really do think that is the future. Whether you're talking about Flink SQL, which is very similar to ksqlDB, or we have this concept of UDFs, user-defined functions, where you can actually put full-blown Java code or Python code into a function and activate it alongside your events. So maybe you want to call out to a third-party API, maybe you want to interact with generative AI, really powerful things you can do with this stream processing portfolio. So again, just to kind of summarize, fully managed data streaming, connectors, cluster linking, stream processing give you the entire, and data governance, give you all the power of data streaming at your fingertips. And to just kind of talk about how we empower the gaming industry directly, right? Build those immersive and gaming experiences, increase monetization with real-time insights, and we're going to talk about real-time insights even more in just a moment. Detect cheating and mitigate toxicity in real time, and our demo speaks to that. Enable real-time monitoring and notifications, and simplify infrastructure complexity with fully managed cloud services. I see, Richard, you came back on camera. Did we have another question? All good. If not, I saw you there. I just wanted to make sure.
No, we do. Thank you for asking, but you kind of answered it. The question was associated to the if we implement both, how do we do Confluent and StarTree? How do we get Confluent and StarTree to work together? Is it via APIs? And you nailed it previously. That came in right before your slide 3 minutes ago, so I chose not to interrupt you.
Cool, awesome. I love when that happens organically. Thank you for that, Richard. So let's talk about some benefits, right? Real-time processing through a whole suite. Could be streams, could be ksqlDB, maybe Flink. Integrate with anything, whether it's your client libraries, or we basically have every flavor of library that can interact directly with Confluent, that producer and consumer API. And then, of course, the connectors, data security and governance, build pipelines with ease, right? That shift left ideology, grabbing data from somewhere, making something meaningful, building that data product, and then move data with low latency. So again, with Confluent Cloud, we're talking 20 to 30 milliseconds of latency for consumer production, of course, assuming you're not hundreds of miles away from your cluster. This is assuming adjacency. I can't change the way light works. The speed of it is kind of fixed, unfortunately. And then let's talk about just some reliability, right? Deliver reliable gaming experiences. I know how important this is. So this is talking about throughput, right? Kafka versus RabbitMQ. This is one comparison of a similar technology. We can do massive scale with Apache Kafka, right? This is 605 megabytes per second. And again, in Confluent Cloud, we have customers using upwards of total of 10 gigabits of throughput in real time. Kind of incredible, massive scale. And then think about latency, right? With Confluent Platform, you can achieve like under 5 milliseconds of latency. With cloud, there's a little bit more overhead. So, it just depends on your latency tolerance. You may decide, hey, we need to run this ourselves, or we can do this in cloud because it meets our latency requirements. But latency is very important when you're thinking about near real time. I actually learned humans perceive real time in about 150 milliseconds. So you got a little headspace there. And then we're able to deliver the reliable gaming experiences because of how Kafka was built from the beginning, right? We have these concept of brokers. Brokers are the systems that ingest and data is consumed from. We build many of them, right? We scale horizontally or vertically, and we have that internal replication mechanism that allows so we have these topics, right? These are collections of events, and then they're split up into partitions, and we can put these partitions across many brokers. One will be a leader, many will be replication. So if one of the brokers, the one on the left, fails, broker 2 or broker 3 will pick up where the partition it was leading, and there's no data loss, very little interruption in connectivity, in many cases no interruption at all. And we're able to do that just because how Kafka was built from the very ground up. And to kind of close out my section, just want to talk about some Confluent integrations with AWS. So we have native integrations with Lambda, with Athena, with EventBridge, very exciting. We have a program called Connect with Confluent, which StarTree is part of as well. We have connections with other third-party ISVs, whether it be other than StarTree, whether it be Snowflake, Elastic, Databricks, or Mongo. And we have quite a few badges. So, I love Pokemon as well. I had to collect them all. So we have 4 AWS service readies, and we have 2 competencies in the form of data analytics and finances. Our financial services. So just before I pass it over to Tim, real time is best, but what do you do? Let's say you have everything real time. You're like, yes, we did it. Everything's low latency, we're killing it. How do you deal with all this real time data and the analytics of it? How do you know that things are going well? Well, you partner with Tim and StarTree. Let me pass it over to him.
Awesome. Well, Joseph, first of all, thank you for that wonderful introduction and the first part of the presentation. And of course, Richard, thank you for you and the team at AWS for sponsoring this. Confluent and AWS are very, very important to StarTree. It has been, and I know will continue to be a wonderful partnership. Before I get started, I checked the participant list and verified that my wife is not on this webinar. So I feel comfortable sharing a little bit of kind of my gaming story. I'm the father of 3 girls. I have a 17-year-old, a 15-year-old, and a 6-year-old. My 6-year-old and I, when my wife is not watching or aware, are very into, of all things, Gears of War. Again, I'm glad she's not on here, but my 6-year-old loves it. We play Halo, we play Gears of War, but only when the wife is not watching or aware. And then secondly, I'm a big and have been a big PUBG player, and I got my 2 older girls involved in it, and we competed as squads, a 3-person squad a lot. And I'll just put this out there. There is no better 3-person squad than myself and my 2 other girls. But anyway, moving on. Why are we here? I'd love to think that the name StarTree and ultimately Apache Pinot are as recognizable as Amazon and Confluent, but I suspect they are not. So I thought I would just spend a moment or two before we get into kind of a little bit of the architecture demo, just explaining kind of who we are, so that you all have some sense of why we're even on this call. But I think hopefully it'll all make sense in just a minute. And Joseph, by the way, is going to be kind enough to advance slides. I hate doing this to people, like, next slide, please. But you are going to have to hear that at least just for the next few minutes. So if you wouldn't mind, let's go to the next slide. And I just want to, again, kind of give this little background of who we are and why. So as Joseph rightly mentioned, Apache Kafka, an incredible piece of technology that is certainly part of the Confluent portfolio, was started at LinkedIn. Well, as it turns out, another interesting piece of technology was also started at LinkedIn right around the same time, and that is what ultimately became Apache Pinot. So sometime in the 2015 timeframe, Apache Pinot was started at LinkedIn. I'll tell a quick story about what that was. But before I do that, just a quick kind of history. Sometime around 2017, 18, LinkedIn donated what ultimately became Apache Pinot to the Apache Software Foundation. The company I work for, StarTree, was founded. And our growth has just been incredible. And we work today with some of the largest companies in the world. And certainly one of our early adopters was LinkedIn. And although I don't have a slide to show you this, it just is a kind of an example of what, for example, problem we were solving at LinkedIn. LinkedIn, as it turns out, with the invention of Kafka, was very interested and used streaming data all over the place. And they wanted to increase engagement at LinkedIn by offering some new features and capabilities. They had this idea of building Who Viewed My Profile. I'm sure all of you have used that feature at LinkedIn before. Without going into all the details, the short story here is that when you go to Who Viewed My Profile today, and you go toggle like, maybe Who Viewed My Profile in California, or, these other things, you're actually executing an Apache Pinot query. And so today, at LinkedIn and all these other wonderful companies, Apache Pinot serves as this really, really important piece of the architecture. Well, what exactly is that and why? I haven't really explained what it is we do. That's just how we got started. And so if you can go to the next slide, I wanted to kind of share just a little bit. And I think this makes total sense, by the way, based on what Joseph was saying, and certainly for gaming. And that is this idea of the time value of data. In almost any industry, and certainly in gaming, when things are happening in a game or outside of a game, the value of that event, the value that that event has to a company, to you as a game provider or developer, really anybody, really decreases over time. This is largely why real-time events, streaming, the technologies we've been discussing are so important, because the farther away we get from that event, the less valuable that data becomes. And you can see left is real-time, high left, that's where all the value is, right? Down in batch, sure, that's wonderful. I mean, there are lots of great things built around batch, but not nearly as impactful from a data perspective as data that's happening in real time. And so, that was kind of part of why, or what, Apache Pinot was built and ultimately StarTree to solve. And by the way, if you think, and if we can go to the next slide, that this is like some little piece of the puzzle, right? Real-time data. It's not. It turns out there's a ton of research here that says like the amount of real-time data that is being generated is enormous. 147 zettabytes in total, 24% of, or what is the number? I get it all confused sometimes. I do, but the reality is it's an enormous amount, right? So not only is real-time data exploding, like if we can't take advantage of real-time data, if we can't gain insights almost immediately from that data, we're missing something. And in the gaming industry, as Joseph said, this is so incredibly important for some of the use cases that we mentioned, right? Whether it's toxicity or cheating, like I have to know these things as they're happening. What good would it be for me to understand that these events are occurring days or weeks following? And so if you can go to the next slide, again, kind of trying to build on this thesis of what Apache Pinot was solving, and specifically, I think, for gaming, traditional data warehousing, I'm sure all of you on this call have had some experience with more traditional data warehousing technologies. They're fine, by the way. They're awesome, but they're batch oriented. And kind of there's three dimensions that I think become really important, and that's kind of latency, throughput, and concurrency. And it's kind of like, or throughput and so what you end up seeing here is that like data warehousing, right? That's okay. That's wonderful for batch data if I need my response in minutes, and if I want to execute like a few simple queries, that's okay, right? That there isn't a whole lot of complexity there. And this idea of throughput, batch and traditional data warehousing is great if I only have a few users in my system, but that doesn't meet the needs of like games going viral, right? What happens if I need to do analytics on this data, not in minutes, but in milliseconds? And I don't want to execute simple queries. I need to do some actual complex queries in order to understand what's happening. And this is where I think, again, Apache Pinot and StarTree come into the picture, as a differentiator maybe from more traditional, data storage, data warehousing technologies, is we're not talking about a handful of users querying this data simultaneously. We're talking about potentially millions of users. And so this is kind of the thesis of Apache Pinot and StarTree, is that the amount of data that's being generated is incredible. Most of that data, or a large majority of that data, is happening in real time. And there's no better place in some ways for real-time data to be mined and used than in gaming. And in order to do that well, you have to have new technology. You can't rely on kind of the traditional data warehouse technology that would have otherwise taken minutes or hours, handled very simplistic queries, or only been able to support a handful of users. So if we can go to the next slide really quickly, kind of in order to do successful, like real-time analytics, and I've kind of touched on this, and this is, again, so true for the gaming industry, at least I hope you believe it is, because we think it certainly is. In order to do successful real-time analytics, this is kind of what I was trying to say, is that there's like these three pillars of things that we have to know and understand and really have in our stack. And that is, I have to be operating on the freshest data. Why? Well, because again, if I'm operating on days old data, my insights aren't nearly as valuable as they could be. So I need to be able to ingest data in real time, act on data, analyze data in real time. There's also this concept, and we won't have time today to go into it, but this idea of upserts, which are incredibly important. So not only do I need to operate on the freshest data, which is, oh, by the way, where Confluent Cloud comes in, I need to have the fastest performance. I need to have a system that I can query and engage with on this fresh data that can do the kinds of queries that I want to do incredibly quickly. And then last but not least, because I know we're running out of time, again, in gaming, this is so important, concurrency, scale, among us, and there are plenty of other examples of games taking off. If I've got to do analytics, if I've got to do fraud detection, if I've got to do, chat toxicity, all these other things, and I can only query these systems at very low concurrency, we've kind of got a big problem. So I want to kind of pivot just very quickly because we are out of time. Certainly, StarTree, the company that I work for, the folks behind Apache Pinot, are a wonderful solution, just like Joseph talked about with Confluent and its relationship to Apache Kafka, among other things. If you're interested in adopting Apache Pinot, doing it at scale, you need to operate on the freshest data, the fastest performance. This is an absolutely wonderful technology to adopt. So if you can, let's just go ahead and skip, Joseph, because we're kind of on time. I want to skip all the way down to 37, slide 37, which is the slide after this. So the good folks at Confluent had built previously a really wonderful demo that they may have shared it, and certainly Joseph can chime in here on a little bit of a description of what this is. But this is out there on GitHub today. And the idea, and I want to kind of walk you through, is kind of the wrap up here, what this was and what we attempt to show. So this is a wonderful demo that originally was built to show, how can Confluent and some other technologies, in this particular instance, Amazon QuickSight, demonstrate their viability in kind of the gaming industry. And so if you go to this GitHub repo, which I encourage you to do, you'll see kind of a quick description of what it's trying to do. And what in fact it is, it's called Pygame, a little Python-based game that runs locally, and it generates a bunch of events, simulates what you would expect, in the real world in a game. And so what this is doing is it's kind of generating this stream of information about players. And then it's generating this stream of information about interactions, or when two players meet. And the original solution used KSQLDB, which you heard Joseph talk about. And what did that do? Well, it took these original kind of raw streams of data and applied some really interesting logic in stream to create what they call kind of enriched streams, which then are made available to S3 and queryable or visualized via Amazon QuickSight. And so I wanted to show you this because I think it serves as a nice contrast and maybe helps you understand how introducing something like Apache Pinot and StarTree might be a little different. And so if you can go to the next slide, what you might be able to do, should you desire to do so, is to solve this problem with a slightly different set, I'll argue complementary, and I'll explain a little bit the difference, but certainly a slightly different set of technologies. And what I did, and I'd encourage you guys to go if you're interested, I forked this repo and kind of made some updates to it. So the link is here with kind of, a more Pinot or StarTree flavor. And so this is where kind of some of the differences between the technologies, I think, can be highlighted. And oh, by the way, all of this, both the demo and really anything we do at StarTree runs on AWS, right? So I didn't put it in the diagram, but you can imagine there's this big block below all of this. So what's really interesting is if I were to run this demo, and I'm going to share screenshots with you in just a second, if I run this demo and I'm generating a bunch of events, right? And I want to go into Confluent Cloud, spin up a cluster and create topics or streams for these events. That's really easy to do. But where Pinot comes into the picture is instead of having to rely on something like ksqldb or even ultimately Flink, to kind of in-stream manipulate these original topics and enrich them and create maybe additional topics or, additional streams, right? What Pinot has the ability to do is operate directly on those kind of raw topics or streams of data. And you may say, well, that's not super interesting. Well, it kind of is. At least it is from our opinion. And here's part of the reason why. We're a SQL engine, we're a data warehouse. And so we can, at scale, like we just talked about, incredibly high scale, with incredibly high performance, supporting very high concurrency. Not only can we actually query these individual streams, we can actually join these streams together natively. So you can execute, a traditional SQL statement, and not just select data from the player table in this case, or the interactions table, but you can actually write sophisticated SQL statements that join these two tables together in real time without the need of doing kind of upstream processing with a Flink or SQL or ksqldb. Now, the question is an obvious one. Well, can you do both? Absolutely. And there's plenty of reason why you might. Maybe there is a particular use case you have where performance is at the absolute extreme. And so instead of executing a query that's joining these tables in real time, maybe you do want to kind of pre-join these topics together and, have it kind of an enriched stream that does some of that heavy lifting for you. But kind of the beauty of inserting Pinot into an architecture like this is that if you don't want to do that or can't do that, you can rely on native SQL to execute these queries in real time. And that makes the solution, I think, pretty impressive. And then, of course, we won't have time to cover. There's all sorts of other interesting things you can do. But then, in this particular case, the visualization layer I used was another Apache project called Apache Superset, which has really good integration with Pinot. So if you kind of scroll back just for a second, Joseph, to the previous slide, you see, you have the ability, if it's your thing, and it doesn't have to be, but you have the ability to kind of simplify with Pinot. And the other thing, if you go back forward, you didn't know you were going to have to go back and forward, did you? When I said you do the slides. But the other thing, and Joseph highlighted this, and then I think we'll quickly flip through the slides. But the other interesting thing that Pinot, I think, allows you to do in StarTree by extension is that while we work incredibly well with these streaming data sources, there may be cases where, in order to really satisfy a gaming use case, you need to be joining or querying or doing analytics on additional data that maybe isn't in a stream. Maybe it's more static somewhere. Maybe it's comes from that awful place called batch. But nonetheless, you want to do you want to inject that data into the analytics. And so Pinot has this ability, really neat ability, through kind of one logical lens, query data from both streaming and more traditional sources at the same time, which is incredibly important, I think. So with that, hopefully that makes sense. Like, what is Pinot? It's this wonderful analytics database, came out of LinkedIn, built really natively to run on Apache Kafka. I didn't in Confluent. I didn't say this, but essentially what we are is an embedded consumer, right? So as data streaming in, we're actually able to execute queries on this data as if it were in and is real time. So it's really, really powerful stuff. So I think because we're at the top of the hour, maybe we won't show the screenshots, but I would highly, highly encourage you take a look at this. Take a look at this URL GitHub repo. Look at the original one, ksqldb, great stuff. Braden and Joseph did a terrific job putting this together. Lots of great information there. But if you're interested, take a look at this fork, because Apache Pinot, I think, offers some really, really interesting capabilities. And again, so complementary to the work that the folks at Confluent are doing. And of course, all of this runs so well on AWS. So big thanks to Richard and team for supporting us. So with that, I'll stop because we are right at the top of the hour. And maybe Joseph, I'll let you, Richard, close us.
Yeah. So real quick.
Right.
Yeah. Just before I get to Richard, just both Confluent Cloud and StarTree are available in AWS Marketplace. We do have the link directly to Confluent Cloud there. So check us out there. Had to plug that. Richard, I'll turn it over to you to announce our winner.
Outstanding. So first and foremost, Tim and Joseph, nice job. That was fun. Learned a lot about your respective architectures, its integration into gaming, and the specific use cases that you align to and some of the problems you solved. Just truly well done in terms of that content delivery. So with that stated, a lot of people waited till the end, which was exciting, and I know they did that because of the content. But I also can appreciate, we have a raffle to give away. So I want to congratulate Alexandra Shumway with Epic Games for winning the Steam Engine mobile console platform. And congratulations, Alexandra. The team will be reaching out to you for delivery of that fine mobile console. It is a nice one, and just want to say thank you to everybody who joined. We welcome follow-up. We welcome the opportunity to take this to the next step as it relates to these technology stacks, its integration into your environment, and the value it can be delivered. So I wish everybody a good rest of the day, and thank you for your time, ladies and gentlemen.